Alright guys, my throat's going, so we'll see how long I can speak. Alright, so there was a lot to say in part 1, and now I wanted to devote this video to the blue version. As soon as I saw the release images, I knew that this is one of those rare combinations in a sauropod I might never again see in a while. Blue is one of my favorite colors, and I get excited just seeing blue eyes on dinosaurs. Imagine that in the skin of a dinosaur, let alone a big sauropod like a 1:35 Mamenchisaurus, something out of this world. It's really striking, but actually, under most lighting, it looks a bit more subdued than the vivid blue I've seen in pictures. I was worried that some of the contrasts might be too stark, but here I see it's a lot more subtle and nicely faded, and nothing to worry about. Let's get to it. Now obviously, it's the same sculpt, so all that loving detail we saw in the brown will be here as well. The main difference is to how the different color palette complements it, and spoiler alert, it does that famously. So starting at the head and neck, you see immediately that blue, and it's nice how the blue eyes mirrors the overall color. You see the face still being rather dark brown, but you also see that towards the lips, how it becomes some of this kind of ochre, and this is going to be reflected later on. Maybe it's fanciful thinking, but the eyes are really looking soulful to me. I just love how nicely it's painted in blue. And you can see already a little of that complexity in the rather simply painted face. Now going down the very long neck, and just like in the brown, the detail really pops. But on this blue and in some lighting, blue-green canvas, that detail shows up sometimes a bit more clearly and more sharply delineated. Again, traveling down, we have those very fine scale detail, and the wrinkling, the folds, and the hints of vascularity running down. And just like the brown, I love how this looks almost like a tight-fitting mosaic of little beads, especially when the light hits it just right. You can see how these are almost purple-brown, very faint spotting in the blue. And ventrally, again that vascular and muscular detail. And you also see what a wonderful use of complementary colors to add a striking visual contrast, accentuating the blue. The transition is so smooth, there's no telling where one color ends and the other begins. And actually, I just noticed this very subtle striping pattern almost sneaking in on the underside of the neck. Then in the body, you again see that muscularity. So here's the deltoid, the latissimus, maybe the obliquus, and here the trapezius. It's interesting, when I saw the release image, I thought it was very vivid and very bright and not very subtle, but here I see much subtlety and not so much of garishness. And here another angle to appreciate that neck going into the shoulder, which is probably my favorite part of the sculpt. There's wonderful richness of detail everywhere. Look at this nice blue fade. Then the subtle striping in the shoulder and arm. Multiple shades of that almost ochre penetrating into the blue. Again, such a nice contrast with complementary colors opposite each other on the color wheel, making for a great visual contrast and yet blending together so smoothly. And then that shift in color down the forearm and the hand. And here you see these very subtle off-white spotting in the body, which I didn't quite see in the brown. And again, such a complex mix. You see just how wonderfully and importantly, naturally the dark markings appear. You see at the base some of those same osteoderms we saw in the brown. Then down the shoulder, look at that muscularity. The arm. The wrinkles in the elbow. The other limb down the thigh. Going down the leg and the feet. And just look at how much detail goes in this small area that's normally not even looked at. If we turn this just slightly over, you see these different zones of color just really sits with the details so well. And again, just having these white spots already gives it a rather different look from the brown. And so it doesn't give you the impression of stenciling that you get with the other Haolonggood color variants. And now going down the tail, suffice it to say, the whole thing is such a huge canvas and not an inch of it wasted. Look at these nice muscle bundles here, which I didn't mention in the brown variant review. And down the tail here, to the end. And like the brown, it again segues into an orange, but this time, instead of just being a flash, the impression is one of cohesion with the color scheme in the rest of the animal. It's interesting, the color, there almost looks to be a beak here. A quick look at the underside. All in all, a very nice model, a very unusual color choice, and speaking of which, let's talk color a bit. So looking at this blue variant got me thinking about colors, and specifically the color blue. So let's talk about that. Now, traditionally, modeling on extant large animals, sauropods have followed the same, with large expanses of grey, brown, or if we're lucky, maybe with a bit of accenting. And there are a few angles to this. First is camouflage. Now, camouflage patterns don't seem to make sense since large animals don't need it because size alone is a protection. In fact, it would be useless because at that size, there's very little they could hide amongst. However, we could also argue that exactly because they're so big, they shouldn't have to fear being colorful and obvious. Now, I personally find it believable that such large billboards might do with some accents of color, just for visual signaling or attraction. However, there's a difference between accents with some color and having a potpourri of garish colors. And even if an animal were big enough to be any color they want without fear, there are two difficulties for our big blue Mamenchisaurus. The first is the availability of pigment. Animals in general cannot create many pigments themselves. They get it by what they eat. I think we know that flamingos are pink because of the vast quantity of carotenoid pigment in the algae, crustaceans, and other organisms they consume. Carotenoids are responsible for vivid reds, oranges, and yellows we see in animals, so different proportions will create different shades of these. Specifically in flamingos, beta-carotene is a key pigment for their pink color. Salmon are pink to red because of the carotenoid astaxanthin. Now, sauropods are huge. To get enough of these pigments, they would have to consume enormous amounts of the right food sources. Now, we humans, with less competition, would still have to eat an obscene amount of carrots for months on end before we get carotenemia. And even in small birds, competition is fierce just to get the relatively tiny amount they need. Now imagine the difficulties of a sauropod thousands of times the size. So these colors would probably be restricted, such as mainly to some striping, mottling, and other modest coverage. Alright, so what else can we do? Well, we can manufacture some pigments, most commonly melanin. Eumelanin is black-brown, and pheomelanin is red-yellow. And that's why in nature, various combinations of these will give you greys, browns, black, and in the absence of pigment, white. In fact, if we consider what are claimed to be melanosomes in exceptional fossils, we find colors like black for Microraptor, grey for Corditerix, brown for 𝐕𝐢𝐞𝐵, or white for Sinosauropteryx. So, for larger expanses in a big animal, whether plain or pattern, these colors make sense. Which is also why, incidentally, as much as PNSO sometimes seems to be trolling us with endless variations of the same brown theme and pattern, in pure scientific terms, they're not wrong to do that. Still, I think that greys, blacks, and whites could still factor in. So, let's quickly talk about the color blue itself. Have you noticed and wondered why so few living things in nature are blue? Well, a big reason is that there really isn't a true blue pigment in nature. There are anthocyanins in plants, but these are pigments that really appear blue or purplish only if the pH is high. Otherwise, at a lower pH, they appear bright red or pink. So, without real blue pigments in plants, animals can't turn blue by eating them. So what else do we have? Well, there's structural pigmentation. Structural pigmentation produces some of the rarer colors we see, such as green, blue, and iridescence. Now, this is seen in animals with specialized structures like scales and feathers, which are shaped to interact with the light in very specific ways. If the overall effect is to reflect blue, then blue is seen. Now, I'll give you some links below if you're interested in the science behind that. But we have fish, beetles, blue butterflies, and the famous birds of paradise. In reptiles, we see snakes, but playing similar light tricks. And part of their colors come thanks to their imbricated scale patterns. As far as I know, based on dinosaur skin impressions, large dinosaurs had tessellated scales. And since we're pretty sure they weren't extensively covered in feathers or gifted with chitin, it's unlikely that sauropods, especially huge ones, had vast areas of bright, vivid colors, and especially of blue. So, as beautiful as it is, this blue Mamenchisaurus can only be considered highly speculative. And given how nice the brown one is, if you're going for realism, then that's the droid you're looking for. May the 4th be with you. Now, alright, not trying to pull a Spinosaurus on you, but I know a lot of you really wanted to see the blue, and there's a lot to see and say about it, instead of just the simple once-over I usually do for the variants. So, I think my throat really is gone, so I'm just going to take a break, and I'll come back and give you the comparisons in a third video. See you soon.